Okay, guys, so today we're going to start on chapter 7. Chapter 7 is about confidence intervals, so we're going to get set up to do that. Um, Basically, what we're going to try to do in chapter 7 and what this intro is talking about right here is we are going to try to make a prediction about the population parameter, whether that's the mean or whether that might be a population proportion or it might even be the standard deviation. But in the beginning, we're going to really focus on the proportion of the population. When they say proportion, don't let that freak you out. That normally just means like what percentage of the population or how many, if 100 people are taking an exam from that population, 17 of them got an A, so that would be a 17%. That's what they mean by the proportion. So what we're going to do is we're going to spend a little bit of time on the point estimate. Let me get rid of this thing. I don't know why that's so basically, we see here that it says a point estimate is a single value or point used to approximate the population parameter. So again, I don't want to say, well, I know for a fact that 20% of the population is going to get an A on this next exam. What I might say is I might say that I would estimate that between 15% and 25% are going to get an A on the next exam. Now, I haven't told you what level of confidence I'm going to be. I just kind of made an assumption. So what we're going to do is we're going to go through and try to test all of that. And we're going, or I shouldn't say test, we're going to try to back up what we're saying. So the thing with the confidence interval is you need a place to start. You need a place to kind of make an educated guess. And then based on that guess, you can kind of dance around the number. Okay. So a point estimate, I'm reading down here. So it says a point estimate only gives us one value to use in order to estimate the population parameter. The point estimate does not tell us how good it is at estimating the population parameter. So my point estimate may be well off, but we got to start somewhere. So a confidence interval allows us to look at a range of values to estimate a population parameter rather than just one number. Definition of a confidence interval is a range of values used to estimate the true value of the population parameter. A confidence interval is often abbreviated as CI. I'll use that all the time, confidence interval, or I'll also use CL for confidence level. A confidence interval is associated with a certain confidence level. Sometimes I'll call that CL. This confidence level is expressed as a probability of 1 minus alpha. So again, they're still going to be giving us alpha. Whatever they tell us alpha is. So if they say alpha is 5% or 0.05, we're going to say that our confidence level is 95% or 0.95. Okay, it's always 1 minus whatever the alpha is. That the confidence interval actually contains the population parameter. So what we're doing is we're trying to say how confident we are that when we build this interval, we're going to build like between 15% and 25%, or whatever the case may be for each problem. We're going to build an interval and we're going to say, I don't know the real population parameter, but I know it's in that interval. Okay, so that's what we're really trying to do, is we're trying to find like a window where we can promise somebody that it's in there. Now, is it possible we could be wrong? Sure it is. Right here, you guys notice it says 90, 95, and 99 are very common confidence levels. So you'll tell somebody, well, I don't know for sure, but I'm 90% confident that the interval will be between 15% and 25%. And again, I'm just using those as random numbers. It could be anything for a different problem. So what we're going to do with this confidence level is we're going to, or I should say, we're going to use a confidence level when we make our statement. We're going to say we're 90% confident, we're 95% confident, we're 99% confident. If the problem doesn't say what the confidence level is, then in general, you assume 95% confidence level. That's kind of the standard go-to confidence level. So if you're working with a problem and they don't say, but they still want you to do it, then you just move forward with 95% confidence level. So I want you guys to kind of look at this right here. So this is kind of a general way that you can make your statement. So in all these problems, you're always going to have to make a statement. You're going to say, here's a generalized template you can use to interpret the confidence interval. It says, we are, and then it says what percent. So you could say, I am 90% confident. The true population parameter, whether it's the true population mean, the true population proportion, whatever the case may be, of such and such, so you put it in the context of the problem, is between 15% and 25%, or between 2 grams and 5 grams. You use a lower bound and an upper bound. So that's kind of your generalized statement. That's how you'll finish up most of your questions. I believe in the homework, you'll also see it that way. Okay, so it says, this is the notation we're going to use, you guys. So we have estimating population proportions. So P is going to be the population proportion. P hat is going to be, so this is P hat right here. That's P hat. P hat is going to be the sample proportion. And the number of sample values, of course, is N. We're going to have something called Z alpha over 2. That's a Z-score separating an area of alpha over 2 to the right of the standard normal distribution. So we're going to do all of this with Z-scores for right now in standard normal. And we're going to have to the left and to the right 2 zones kind of separated by this, okay? I'll show you when we get into one, okay? So in this first one, so let's go over here. So in this first problem, it says, during the last electoral race, it was found that 67% of registered voters in Indianapolis were Republicans. To test a random digit dialing system, 150 Indianapolis phone numbers were randomly dialed, and the individual who answered was asked their political affiliation. Of those contacted, 73% said they were registered Republicans. Identify whether the bold percentages above are statistics or parameters and use appropriate notation. So first of all, we know that they want us to call the percentages. So the 67% or 0.67, is this P or is this P hat? So it says during the last electoral race, it was found that 67% of registered voters in Indianapolis. So is that a sample, or is that saying everybody in Indianapolis? Everybody in Indianapolis, right? So that would be our population. That is equal to P. And then we have 73%. That would be our sample percent, and that would be P hat. So again, you're just going to identify your sample proportion as P hat in general, okay? I'm not going to go too crazy into this requirements for estimates of proportion because I'm going to want you to do it. Every once in a while, I might try to trick you in the homework to see if you try to do it when you're not supposed to. But I would say in general, we're going to say that this will work for our class. Now, if you were in the field and you were doing actual statistical analysis and you were trying to build a confidence interval yourself as part of your job, you would definitely have to go through and verify all this. So it says requirements for estimates of proportion. The sample is a simple random sample or a random sample. The 4 conditions for binomial are satisfied. And if you guys remember, that was a fixed number of trials, independent trials. So it was an independent set. And there was, I think, at least 5 successes and failures of each type. And then you knew P hat and Q hat had to add up to 1. You could find Q hat by doing 1 minus P hat. Okay. So and then there's at least 5 successes and failures. So yeah, this is kind of our bread and butter. This is something we're used to from chapter 5 in the binomial. So it says sample proportion P hat is the point estimate for the population proportion. Okay. So in general, what you're always going to want to do first, okay, you guys, this is kind of muddled up right here. So let me write this better for you. This is P hat plus or minus E. And hopefully your notes are better than this. If not, you can fix it in your notes. This one says P hat. Oops, let me fix this real quick. We're going to put parentheses P hat minus E, comma, P hat plus E. I don't know how it got shifted down like that. Sometimes the transition from the PDFs just doesn't quite work right. So it says the margin of error is the maximum difference between the observed sample proportion P hat and the true population proportion. To find the margin of error, so this is extremely important right here. Finding this E right here is kind of all the work that you have to do. I'm going to show you how to do it on the calculator as well, but I want you to do it by hand also so you don't just feel like you're hitting enter, okay? But I want you guys to understand what this is saying right here. So what this is saying here is whatever you get for your P hat, your point estimate, okay? So the point estimate is extremely important. It's kind of your starting point. It says whatever you get for your point estimate, you're going to subtract the error and you're going to add the error, and that's going to build your interval. That's going to build your window. So the first thing you need to know is you need to know P hat. Then the next thing you need to know is you need to find your error. And once you find those two things, you can build your confidence interval by simply adding and subtracting the error from your estimate. Now, if you want to think of it, the p hat is it's kind of like your best guess. You're saying, I think this is what's going to happen. It's based on this information. It's based on this sample. And then we're going to build a window around that estimate. Okay. So these are remember I told you guys earlier that these confidence levels, 90, 95, and 99 were the common ones. So these are levels of confidence. And over here, you see that it gave you the critical value. So you can memorize these. Obviously, you're going to be having these on your cheat sheet, but these critical values are associated with them, okay? Now you have to understand that this is Z alpha over 2. So make sure you understand that this is a critical value when you're using alpha over 2, not just Z alpha. There will be situations in hypothesis testing where we will just do Z alpha, okay, or Z sub alpha. In this case, we're using Z alpha over 2. So make sure that you understand this is associated with taking alpha and cutting it in half because you have two different sides that you're separating off. And you'll see graphically what that means. Basically, you're doing this. You have this section over here and this section over here. And then you have this and you have that. Okay, so that's Z alpha over 2 is splitting whatever alpha is and cutting it in half. So if you're doing 90%, let's say, then you have 0.05 over here and 0.05 over here. Okay. And so you would do the same for 95 and 99. You would cut the leftover alpha in half. Okay. So it says interpretations for confidence intervals. We are 90%, we are 95%, we are 99% confident. So when we're working with this is just, oops, sorry about that. I thought I selected my highlighter. When we're working with this, we're kind of just saying that this is our general way we're going to state our conclusion. So just kind of get used to writing that. Okay. So I think we need to try one. There's been a lot of talking and not a lot of working. Okay. So let's actually get started on this one. It says, the drug Lipitor is meant to lower cholesterol levels. In a clinical trial of 875 randomly selected patients who received 12 milligram doses of Lipitor daily, 53 reported headache as a side effect, okay? So it says, what is the point estimate for the true population proportion of Lipitor users who will experience a headache as a side effect? So basically what we're trying to do is this problem is going to lead us down this path where we say, basically, you know, what would the expected population proportion, or what percentage, however you want to look at it, of the population would we expect to experience headaches as a side effect? Now you understand that the first thing they want to know is the point estimate. That's where we need to start. So we're going to say P hat is equal to 53 people had a headache, okay? And there were 875 in that sample. Okay, now you guys understand, we're trying to use the point estimate to talk about all of the population, okay? We're taking the sample of 875 and we're trying to use it to make this interval to tell somebody, well, I don't know for sure what percentage of the population will, but it's gonna be somewhere in this range, somewhere in this window. Okay, so when we plug that in, we're gonna get 0.0606. Let's use 4 decimal places. So you can kind of think of P hat as X over N, okay? How many people experience whatever you're dealing with? In this problem, it was a headache as a side effect, divided by N, the total number of people in the study or in the sample or whatever you're working with for that problem, okay? Verify the requirements of constructing a confidence interval for a proportion are satisfied. So we know number 1, this is random, yes, check. Number 2, we have to kind of go down the binomial list. Let's say fixed number of trials. Check. Okay, are they independent? Yes, independent. Check. Success, is it clear what is a success? Yes. In this case, oops, let me erase this for you guys a little bit. Success equals headache no success or failure is no headache. Now, again, I don't want you guys to think of success and failure as positive and negative things. It's just meaning for this problem, if you have a headache as a side effect, that was considered a success in this study, okay? And then we have, let's see, I'm running out of room. D is P hat is equal to 0.0606. But if P hat is equal to that, then we can find Q hat very easily by doing 1 minus 0.0606. So I'm going to do 1 minus 0.0606, and I get 0.9394. All right. Okay, so let's see here. I think I have everything that they asked me to. There are at least 5 successes and at least 5 failures. Check. Right. So this is 3. So this is check, at least 5 success. And there's obviously 53 people that have a headache, and obviously much more than 5. There's 800 and something, 822 that did not have a headache. So everything checks out. We're feeling pretty good. So we know we can use this method that they showed us up here, this way to calculate error and way to build our confidence interval. So we're going to come over here and we're going to say construct a 90% confidence interval for the population proportion of Lipitor users who will report headache as a side effect. Okay, so, well, I already know my point estimate. So according to them, if I go up here, if I scroll up, you guys see that we need 2 things. We need our point estimate and we need our error. Well, we already know our point estimate, so let's find our error. And our error is done by, or found by, using Z alpha over 2, which we now know our critical value, Z alpha over 2 for 90%. We're going to use this guy right here, 1.645. Does everybody see why you're using 1.645? Take a minute, really think about that. Because that's the level of confidence I have, so this is my critical value, okay? Now you could go on your calculator and you could go inverse norm. You can go second varse, inverse norm of 0.05, and you would get negative 1.645, and you'd get positive 1.645. These 2 numbers come from the fact that it's 90%. I have 5% in the left and 5% in the right. That's where I'm getting these 2 numbers from, is if alpha is worth 0.1, when I divide that by 2, I'm going to get alpha over 2 is worth 0.05. That's where I'm getting this from, and that's where I'm getting that from. Okay, just so you guys know. Okay, and you could do this for any of these. If you wanted to do 95, well, then your alpha is 5% or 0.05. You take 0.05 and cut it in half, and you get 0.025. Okay, and that's where we get 1.96 from if we do inverse norm. Now they choose to use the positive because if you look at our formula, right here, you see how it says plus or minus. So it's not really going to matter if you have the negative, because if you have the negative, then it's going to become the plus, and if you have the plus, it's going to, it'll work out. So they choose to always just use the positive version. Okay, so we're going to come back over here and we're going to construct our 90% confidence interval. So we know our P hat, so we're going to say P hat plus or minus, oops, yeah, sure, plus or minus our error is going to equal our confidence interval. Okay. So we know that P hat is equal to 0.0606, right? Now we have to find plus or minus the error. So I guess I could write it separately. So we could say the error is equal to, we have our formula of Z alpha over 2, Z alpha over 2 times the square root of P hat times Q hat all over N, right? So that's the formula that we're going to use, okay? So I'm going to write this over here. So I'm going to say error is equal to 1.645. And again, where did I get that from? Right here, my critical value, 1.645. right here. I'm going to multiply that by my square root of p hat, which is 0.0606 times my q hat, which is 0.9394, divided by n, which in this particular problem is, I believe, 875 here. Okay, let's do this real quick. So we have E is equal to what? So I'm going to do 1.645 times second function square root of 0.0606 times 0.9394 divided by 875. And I get approximately 0.013, let's say 3. Let's round off to 4 decimals. Okay, so that means that I'm going to do p hat. Okay, so that's a very important number right there. That's a very, I'll highlight that. We're going to use that. That's our error. And we know our p hat is right here. So we're just going to take these two numbers and we're going to do p hat plus or minus our error. But that is equal to, you know what, let's do it like this. You know what, yeah, I like equals first. So let's do p hat of 0.0606 plus 0.133. Oops, 0.0. I don't want to confuse you guys. Let's just do 0.0606 plus or minus 0.0133. So that means that we can now build our interval of, I'm going to do my calculator, 0.0606 minus 0.0133, and I get 0.0473, comma, and now I'm going to do the other one, 0.0606 plus 0.0133, and I'm going to get 0.0739. Okay, so that is my confidence interval. That is my confidence interval right there, 0.0473 and 0.0739. And all I did, you guys, is I took my p hat, which was my point estimate of about 6%, and then I added and subtracted about 0.0133. So about 1% I added and subtracted. So now we have to interpret our confidence interval. So this will be expected in the exam, the homework. They'll always, or not always, but a lot of times they'll ask you to follow up your confidence interval with a statement. So we are 90% confident that the population proportion of Lipitor users who experience headaches as a side effect are between 0.0473 and 0.0739. An alternate to this is you could just write the interval 0.0473. I believe I would take either one of those. So this method or this method, I believe would be good. But you have to basically use words now. You have to actually explain what you just found. Let me clean this up. Okay, as a side effect, are between 0.0473. So what you're telling somebody is you don't exactly know what percentage of the population experiences headaches as a side effect. But you're 90% confident that whatever the percentage of the population truly is that experiences headaches as a side effect is in between 0.0473 and 0.0739. So basically you're saying about a little over 4.5% up to about 7.5%, not quite. That's what you're basically telling somebody. You don't know for sure the answer, but it's somewhere in there. That's the power of a confidence interval, is you don't actually know the correct answer, but you know it's in between here, okay? So notice what I'm saying is it's somewhere in here. I don't know whether it's 5%, 6%, 7.1%. I'm not exactly sure, but I'm 90% confident it's going to be in there somewhere. So that's what the sample and the point estimate allowed us to do, is it allowed us to make a prediction about the population, okay? So now this is kind of a big deal right here, you guys. So take a look right here at this bottom section. So I need you guys to look at that, and it says you will be happy to know that your calculator will find the confidence interval for you. Stat test 1 prop z interval. Okay, so let's try that. Let's go to stat, test, and then we're going to go all the way down to 1 prop z int. Okay, so let me see. On my calculator, it's letter A, so it's kind of towards the bottom. 1 prop z int. It asked me for x. Okay, in my case, what's my x? Well, there were 53. What's my n? There's 875. What's my confidence level? 90%, so I did 0.9, and I hit enter. And it gives me, so from calc, so from the calculator, it gave me a slightly different confidence interval, 0.04731. That's about the same as ours, okay? And then 0.0473, so that matches that guy, and 0.07384, 0.0738, okay, 4. So they would have rounded down, we would have rounded up to 9, but that's because we use 0.0606, 53 divided by 875. When we did 53 divided by 875, we rounded off, okay? So there's gonna be a little bit of built-in error in there. The calculator is actually more accurate than us, but if you have to do it by hand, this is the way to go, right? So this, you find the error right here. That's the first thing you find. You should already know the point estimate by the time you start the problem, and then you just add and subtract those two things and you'll build your interval. Smaller number always goes on the left when you're dealing with intervals, okay? So that is the first one, and that's how to do it by hand, and that is how to do it on the calculator. Okay, so let's see what the next one is. Okay, so it says in 2004, the Pew Research Center for People and Press reported that 28% of 1,149 US adults surveyed would not vote for a political candidate who disagreed with their views on gay marriage. So it says construct a 99% confidence interval for the population proportion. For X, find 28% of 1149. So sometimes you'll have to do this and you round to the nearest whole number. So we're going to do that real quick. So we're going to find our X, okay? So we're going to say X equals 1,149 times 0.28 because they said 28% of the 1149. So we're going to do that. We're going to do 1149 times 0.28. And this becomes 321.72. Okay. So we're going to use, let's use 322. So we're going to use 322 for our X. Okay. So now I want to try to practice using my calculator real quick on this one. Let's kind of go through what do we know? Do we know N? Yeah, N is 1149, so 1,149. Do we know our confidence level? Confidence level. Yeah, it's 0.99, right? So we kind of know everything we need. So we could do it by hand, but if I want to go quick, I could just do 1 prop z int, and this would give me 322. And if you do this test, when you're taking the test by hand, I would expect you to write this. This is required for you to write right here. Tell me what you're putting in your calculator right there, okay? So one prophecy in 322, 1149, and then confidence level 0.99. Okay, so let's close that up. Okay, so let's do that again now that we have some practice. Second. Let's go to stat tests. One prop z int. We have x is worth 322. We have 1,149. We have a confidence level of 99%. Oops, messed up. My calculator froze. Okay, let's do that again. So they give me my confidence interval is 0.2461, comma, 0.3143. Oops, 44. Let's So that's my confidence interval of about 24, almost 24.5%, and about 31, almost 31.5%. Okay, so it says we are, what did we just find? We are 99% confident. I'm going to kind of abbreviate around the room. That we could say true population proportion or the population proportion, which is a fancy way of saying the percentage of people who would not. So again, you got to incorporate the problem back in. Not vote for, oops, sorry about that, you guys, for a candidate who disagreed, and I'm just rereading the problem, who disagreed with their views of gay marriage. So when we read this again, we are 99% confident that the population proportion of people who would not vote for a candidate who had disagreed with their views on gay marriage is between, and here's where I bring in the confidence interval, 2461, comma, 0.3144. I did my job. So you're telling someone, I don't know for sure what the exact number is, but I'm 99% confident it's in between here. I'm 99% confident it's in between here. This is the population proportion based on this sample of US adults, okay, who I believe would not vote for a candidate who does not agree with their political view on gay marriage. And this is basically saying that I'm already understanding that I don't know that answer, but I can tell you it's in between about 24% and 31%, somewhere in that range, okay? That's what confidence intervals do. Is it possible that I'm wrong? Well, sure. I only said that I'm 99% confident. So is it possible that the sample misled me and I made a mistake? Yeah, that could all happen. But again, I'm pretty darn sure. 99% is pretty high up there, okay? So just keep that in mind when you're doing these types of problems, okay? So let's see what else we got here. So it says to find the point estimate p hat from a confidence interval, you could do p hat is equal to the upper limit plus the lower limit divided by 2. And again, this, if you think about what they're saying, this makes sense because p hat is smack dab in the middle, right? So if you take the upper limit, and remember when you built the confidence interval, okay, and you built the lower limit and the upper limit, didn't you take p hat and add the error to it and take p hat and subtract the error to it? So what they're saying is if you just take those two numbers and add them and then divide by 2, find the average of them, that will be p hat, okay? So that's another way that you can find p hat given upper and lower limits. I'm pretty sure that you'll see these in the homework because if you know what you're doing, it's a kind of almost like a trick question because they tell you the confidence interval ahead of time. And then they want you to kind of backtrack and see if based on a confidence interval, could you tell me what p hat was? Or based on a confidence interval, could you tell me what the error was? Okay, and that's what the bottom one is. It says to find the margin of error E from the confidence interval, you just take the upper limit minus the lower limit and divide by 2. So then what you do is you find the difference between the upper limit and the lower limit and then cut it in half. And that's how much you had to walk left and right of p hat. So this is kind of it doesn't happen all the time, but it's a way that if you're given the confidence interval, you can backtrack and get back to the p hat and the error, okay? So let's see. It says a random sample of students who took the SAT twice found that 427 of the respondents had paid for coaching courses the second time around, and that the remaining 2,733 had not. Find a 95% confidence interval for the true proportion of students who had coaching courses the second time they took the SAT. So we're going to just try to go like straight calculator on this. We'll do some more by hand later on, but let's just go straight up into the calculator for this. We're going to write down what we know. Oops, sorry about that. We know that X is worth 427. Those are the ones that got coaching the second time around. We know that N is worth what? Well, you got to do this. You got to take a second. There's 427 that took coaching, and there is 2,733 that did not. So that's a total of 3,160 if you add those up, I believe. Yeah, looks good. And then we always need to know our confidence level. Our confidence level is 0.95 or 95%. So I'm just going to do, we look back up here. What do they say the calculator can do? 1 prop z int. So I'm going to go 1 prop z interval. And this is going to spit out our interval for us. So we're going to do just like before, through our X value. In this case, it's 427. Our N is 3,160, and our confidence level is 0.95. So I'm just going to take out my calculator. Second parse, not second parse, sorry, stat test. Let's say here, I said 427, 3160, I believe, and then 0.95 confidence level. Oops, if you hit the answer twice, if you hit enter twice, I did that last time, that's how I screwed up my answer last time. If you hit enter twice, it goes past that and does something else. So let me try this again. Enter once and I get my answer. I get 0.1232, comma, 0.1471. Okay. So what, now here's the thing, something that's important to understand is at this point, maybe you guys are kind of feeling like, you know, I just feel like I'm hitting enter on the calculator. I don't know what I'm doing. Well, then we're going to have more practice going over it by hand. But what you really did is, and I don't know if your calculator does it, but my calculator actually tells me p hat was about 0.135, so about 13.5%. So you're telling someone that based on this sample, about 13.5% of the people who took it twice went back and got coaching for the second time around. So 13% of them, okay? That's not really, if you really think about it, that's not really good. If you're gonna take the SAT twice, you should, you know, take it once and then you realize what you messed up, go get coaching, figure out a way to do better on it. So only 13.5% of the people in this sample that took the SAT twice ended up getting coaching the second time around. And again, you don't, and I'm sorry, that was from this sample, but how does that say the whole population is going to behave? So what they're saying is they're saying that, sorry guys, my battery's going to die real quick. So what they're saying is that you don't know for sure how the entire population is going to behave, but you're 95% confident that the percentage for the population will be somewhere in between 0.12 and 0.14, or about 12% and almost 14.7%. So that's what you're telling somebody. So that's what we're going to interpret now. We're going to say we are 95. And again, I'm not being fancy. I'm kind of doing all of these the same. Obviously, if you guys go on to be statisticians or whatever, you're going to come back and, you know, show me, hey, Professor B, you could have done this, you could have done that. That's 100% correct. But we're just trying to go with the generic, straightforward intro level statistics course. So we're going to kind of stick to the same mold that we've been using. We are 95% confident, or you could say even 95% sure that the population proportion, or the true population proportion, of students that paid, who paid for coaching the second time around on the SAT would be between, you could say 0.1232 and 0.1471. And you could even do percentages. You could even have done this 12 point, you know, maybe because talking to somebody, percentage would make a little more sense to them. So you could do it that way. And both of these would be correct. This is correct as well as this. Either one of those would have been right. But you're just explaining to somebody that I don't know the correct answer. I don't know the exact way the population will behave, but I know it's going to be somewhere in between 12.3% and 14.7%. That's how many people in the population, I believe, are going to pay for coaching the second time they take the SAT. And I'm not 100% sure, but I'm 95% confident. Okay. So that should definitely get you guys started. How many pages do we have left here? Let me see if this is a good place to stop. Let's see. I think we could do one more. Okay. So it says sample size. Obviously, I'm going to make another video for the end of chapter 7, and I also have a few side problems that aren't in the notes. I'll probably do the next video with those in them, where I'll just kind of write them on a separate sheet of paper, and we'll kind of go from there, just to give you guys more examples on how you should expect things to be showing up on the exam and in the homework. So it says experimenters often use statistics to determine how large a sample they need to collect in order to conduct an accurate experiment. If we want to fix the margin of error with a certain level of confidence, a particular z-score, we can determine a number of subjects and need in the sample. So something I want to remind you guys of is z-score. I don't feel like we've been doing z-scores, but now I want to scroll back for you guys. I want to show you so we don't lose track of what we're doing. So because we've been doing this on the calculator so much, I think you guys have lost track maybe. Look right here. It says, how do you build the error? Right here, it says that in order to build the error, let me use this one. In order to build the error, we have to use that value right there, 1.645. Where did that come from? That came from a z-score from the normal distribution. This is a critical value, okay? So z-scores and critical values are kind of the same, but critical values take on a certain meaning in confidence levels and hypothesis testing. And it's very important that you understand the difference between a normal regular old z-score and a critical value, okay? The critical value is separating the left and the right sides of the normal distribution. And it's based on our confidence levels, which number we use. Since we're using a 90% confidence level in that previous problem, we use 1.645. I believe in the other problem, we use a 95% confidence level, so we use 1.96. Now, you won't notice using these values because what have we been using? We've been using one prop z int on our calculator, but the calculator is doing this problem for us. So never lose track. We are still using z-scores. It is definitely still a part of the problem, okay, and a way to find these calculations. So now we're going to kind of go back and do some of this by hand. So it says here, oh man, it's messed up on my page again. So let me write it over here for you guys. I don't know if it's messed up, so I'm going to rewrite it for you. N equals, on my notes, it's messed up, but hopefully it came through correct on yours. On my notes, it's z alpha over 2. That's a pretty ugly alpha. Let me fix that for you guys. Same thing. Sorry about that. Z alpha over 2 squared, p hat, q hat. So you multiply these, and then you divide it by the error squared, okay? This next one is, this is if p hat is unknown, this one down here. If you don't know p hat, you use that one. And you see this 0.25? This 0.25 right here? Well, what they're saying is if you don't know p hat, just kind of guess p hat is 0.5, and then that means q hat is 0.5. And if you take 0.5 times 0.5, you get 0.25. So they're just saying kind of eyeball it or estimate it with that if you don't know p hat. This is again where statistics sometimes, you know, is a little hard for people to swallow, because they're saying you don't know p hat, but you still want to guess, you still want to estimate. So we're still going to be able to do it. So sometimes you just have to do the problem, whether you have everything that's needed or not. You just give it a shot. And I told you guys in class that sometimes statistics does that, where it's the best you can do, so you make it work. Okay. So it says the ways that we communicate have been dramatically affected by the use of answering machines, voicemail, and email. Suppose a sociologist wishes to determine the current percentage of US households using email. How many households would she have to sample in order to be 95% confident that the sample percentage is within 4 percentage points of the true proportion? Okay, so it says, suppose we have no prior estimate for p hat. So that means that's this guy right here. This guy right here says you have, if p hat is unknown, use this formula. So we have no data, we don't know what to do, and we're going to go through and do this. So it says, the formula says that we're going to use n equals, now again, remember, we're not finding a confidence interval this time. We're trying to find out how many samples we need to take in order to be this certain level of confident with this certain level of error. Okay. And it says n is equal to z alpha over 2. So in this case, what's our z alpha over 2? It's 1.96. Okay, and then we square it. It's 1.96 because, once again, let me take you guys back and scroll up here. See this table right here? My confidence level is 95%. So if it's a 95% confidence level, well, then that means that I have to be, I have to use 1.96 as my critical value. Okay. So let's go way back down here. Let's use 1.96 because the problem told us that we're 95% confident. You see right here, they told us 95% confident within 4 percentage points. Okay, so that'll come back later. We're going to need that in a second. What are we going to use for our p hat and our q hat? Well, we don't know p hat, we don't know q hat, so we're going to assume they're both 0.5, and that means that we get 0.25. So we're once again just using the formula that was given. Let me make this a little bit nicer, you guys. And then we're going to use our error. But what's our error? Well, it says households would have to, so right here, I'm reading right here, she has, would she have to sample in order to be 95% confident that the sample percentage is within 4 percentage points of the true proportion. So we don't know the true proportion, but we want to be within 4 percentage points plus or minus. We don't really care which way, we don't care the exact value, but we want to be within 4%. So our error is given to us as 4%, and we square it. So I'm just following the formula. You guys understand? I'm just getting that from this formula right here. So then when I do that and I plug that in my calculator, I'm going to do 1.96 squared. I'm going to multiply that times 0.25, and then I'm going to divide that by 0.04 quantity squared, or not quantity squared, just squared. And I get 600.25. Now here's where, oops, 0.25. Now here's where you have to be a little bit, careful. Okay, so we get 600.25, all right? And that means that we have to have this number of households. So if I take 600 households, is that technically enough? No, it's not, because it says you actually need 600.25, another quarter of a household. Well, you can't actually take a quarter of a household. So just to be safe, what we're going to do is we're going to round up to 600. You know what? I'll write it down here. We're going to round up to 601 households. And man, I must be running out of steam, you guys. I cannot. Okay, so it would take 601 households. Now I know you would say, technically 600.25 rounds down, right? But we're trying to err on the side of caution. So we're going to take one more than we need just to be sure that we have a full 600. Okay, so we have 601. Okay, and it says, suppose she uses an earlier estimate from 1997 that found that 16.9% of US households use emails. How many households would you then have to sample? So now, by them telling us this right here, by them telling us 16.9%, they're actually giving us a point estimate. They're saying this is a starting point. Now, you guys, I'm not a statistician, so I don't know what the time limit is, but there's a lot that's changed over the last 20 plus years. So if this is from 1997, I would say the use of cell phones and everything has caused a lot more internet and everything to be used in houses. So I think this might be where you need a little bit more recent estimate that's gone through that. But again, we're just going to go with what we're told, and we're given a point estimate of 16.9%. So we're going to do the same exact problem, but we're going to use this other formula up here, Z alpha over 2, which will still be 1.96. We're still going to square it. And then we're going to do P hat, which is 0.169. So I take 16.9% and I convert it. And then I also do 1 minus 0.169, and that'll give me Q hat. So 1 minus 0.169, or you could just put it in your calculator, and you guys should be able to do it. And we still divide by 0.04 squared. So this time, when I plug this in my calculator, you get 1.96 squared times 0.169 times 1 minus 0.169 divided by 0.04 squared. This time I get 337.19 households, 337.19 households. Okay, so again, we'll take 338. So this time we would need 338 households. So I hope you guys see that by having some point estimate, somewhere to start, somewhere to make an educated guess, somewhere to dance around, the number that you need to dance around. By having some kind of point estimate from a sample or a previous study, it can almost, I mean, in this case, it almost cut down on half of our work. We only had to interview 338 houses versus 601. Okay, so having a previous estimate can really, really help with that problem. Okay. So let's just go over this last one, and then I think we'll call it a day. This will be our first video on chapter 7. It says a sociologist wishes to conduct a poll in order to estimate the percentage of Americans who judge that affirmative action programs for minorities and women should be continued at some level. What sample size should be obtained if she wishes to estimate if she wishes the estimate to be within 3 percentage points of 95% confidence? So she does not use a prior estimate, so we're going to go right back to it. We should be getting better at this by now. We need to use Z alpha over 2, but in this case, Z alpha over 2 is it 95? Oh, it's 1.96 again. And again, this would only change if we changed our level of confidence, okay? We know our P hat and Q hat, we're not using a prior estimate, so we're going to use 0.25. Let me put this squared up here a little bit better. Divided by, what's the error? To estimate with be within 3 percentage points, so 0.03, that's 3%, and we're going to square it. So let's see what we get. 1.96 quantity squared. Did it again. Times 0.25 divided by 0.03 squared. And I get 1,067, 111, so on and so on. But I hope you guys are starting to notice that we're going to round up to 68. So we need 1,068, okay? What sample size should she should have 1,068 for her sample size if she has no prior estimate. In this one, we're going to use the same thing as last time, 1.96 squared. But this time they're saying that we know an estimate of 85% obtained from CNN polls. So we know our population proportion estimate P hat. We're going to use 0.85. That means that Q hat has to be 0.15. Remember, I'm just doing 1 minus P hat. Okay. And I believe we, yep, still divide by 0.03 squared. And we should get 1.96 squared times 0.85 times 0.15 divided by 0.03 squared. And I get 544.23, but we know that we're going to take 545 as our sample size. So I hope this gets you guys started on chapter 6. This is kind of an intro. Video went a little bit longer than I normally go, but I might start trying to do like hour-length videos or something like that to try to finish up. We got more to do in the following sections, but that's going to be it for today, guys. Okay, I'm going to end the video.